Welcome back. So our today topic is reliability of the assessment tools. What are the objective of this chapter? In this, after studying this unit, uh, a teacher will be able to do the following steps. Like the first step included that they define reliability in their own words. The second is they apply the different methods of assuring reliability on the test. The third is they identify the factors that affect the reliability, and the next is they construct a test and check how much reliable it is, and the last is they identify measures for reducing the problems in conducting the test. Now, what is the mean of reliability? What is the definition of reliability? So, reliability means trustworthy. A test score is called reliable when we have reasons for believing that the test score is to be stable and objective. For example, if the same test is given to two classes and is marked by different teachers, even then it produces the similar result. It may be considered as reliable. Stability and trustworthiness depend upon the degree to which score is free of chance error. We must first build a conceptual bridge between the question asked by the individual, for example, are my score reliable, and how reliability is measured scientifically. When a person think of reliability, many things may came into his mind. The first is my friend is very reliable, my car is very reliable, my internet bill paying process is very reliable, and all the different things. So my client performance is very reliable, and so on. So the characteristics being addressed are the concepts such as consistency, dependability, predictability, variability, etc. Note that implicit reliability statement is the behavior, machine performance, data processes, and work performance may sometimes not reliable. According to the dictionary, that reliability is the extent to which an experiment, test, or measuring procedures yield the same result on repeated trials. According to the author, that reliability is the consistency of observation yielded over repeated recording, either for one subject or a set of subjects. The next definition of reliability includes that the extent to which results are consistent over time and accurate representation of the total population under study is referred to as reliability. And if the results of a study can be reproduced under a similar methodology, then the research instrument is considered to be reliable. Now, what are the types of reliability? It has to do with the consistency or reproducibility of an examinee's performance in the test. It is not possible to calculate reliability exactly. So, there are six general classes of reliability estimates, each of which estimates reliability in different way. The first is inter-rater or inter-observer reliability. In this, to assess the degree to which a different rater or observer give consistent estimate of the same phenomena. So that is if two teachers mark same test and the result are similar, so it indicates the inter-rater or inter-observer reliability. The next is test retest reliability. In this, to assess the consistency of a measure from one time to another, when a same test is administered twice and the result of the both administrations are similar, this constitutes the test retest reliability. The third is parallel form reliability. In this, to assess the consistency of the results of the two tests constructed in the same way from the same content domain. So here is the test designer try to develop two tests of the similar kind, and after administration the results are similar, then it will indicate that there is a parallel form of reliability. The fourth step is internal consistency reliability. To assess the consistency of the result across items within a test, it is correlation of the individual item score with the entire test. And the fifth include that split half reliability in this to assess the consistency of the results comparing two halves of single test. These halves may be even odd item of on the single test. The next is to assess the consistency of the result using all the possible split half of a test according to Richardson. Let's discuss each of these in a turn. Inter-rater or inter-observer reliability. Further explanation included that whenever we observe our activities of the human, we have to think about the procedure for reliable and consistent results. For this, two or more than two observers are assigned to observe the students or teachers. So, how do we determine whether the two observers are being consistent in their observations or not? We probably should establish inter-rater reliability by considering the similarity of the score awarded by the two observers. There are two major ways to actually estimate the inter-rater reliability. If your measurement consists of categories, the rater are checking off which category each observation fall in. You can calculate the percent of agreement between the raters. For instance, let's say you had 100 observations that were being rated by two raters. For each observation, the rater could check one of three categories. Imagine that 86% of the 86 out of 100 observations, so the raters check the same category. In this case, the percent of the agreement would be 86. Okay, it's a crude measures, but it does give an idea of how much agreement exists and if it work no matter how many categories are used for each observation. To other major way to estimate the inter-rater reliability and appropriate when the measure is a continuous one. So there all you need to do is to calculate the correlation between the rating of the two observers. For instance, they might be rating the overall level of activity in a classroom on a 1 to 7 scale. You could say, have them give their rating at regular time interval, for example every 30 seconds, and the correlation between these rating would give you an estimate of the reliability and or consistency between the rater. One might think of this type of reliability as calibrating the observers. There are other things one could do to encourage a reliability between observers, even without estimating it. The next is test retest reliability. So the further explanation of this is included that the test retest is a statistical method used to determine a test reliability. The test is performed twice. In the case of a questionnaire, this would mean giving a group of participants the same questionnaire on two different occasions. So this form of reliability is used to judge the consistency of result across items on the same test. Essentially, you are comparing test items that measure the same concept to determine the test internal consistency. So we estimate test retest reliability when we administer the same test to the same sample on two different occasions. This approach assumes that there is no substantial change in the construct being measured between the two occasions, so the amount of time allowed between the measure is critical. We know that if we measure the same things twice, that the correlation between the two observations will depend in part by how much time elapses between the two measurement occasions. So the shorter the time gap, the higher the correlation, and the longer the time gap, the lower the correlation. This is because of the two observations are related over time. The closer in time we get, the more similar the factors that contribute to error. Since this correlation is the test retest estimate of reliability, you can obtain considerably different estimate depending on the interval. Half reliability. Suppose you have to develop a test of 30 items and you want to know that how reliable the test is. What you have to do is to administer the test, mark it, and divide it into two parts in such a way that place all the even number items like 2, 4, 6, 8 up to so on in one half, and on the odd number item 1, 3, 5, 7 up to so on in the second. And then you calculate the reliability by using the Spearman-Brown prophecy formula given below. Actually, in split half reliability, we randomly divide all the items that claim to measure the same content in the two sets, and we administer the entire instrument to a sample of students and calculate the total score for each randomly divided half. And split half reliability estimate is simply the correlation between these two total scores. So normally a single test is used to make two shorter alternate forms. This method has the advantage that only one test administration is required, and therefore memory and the practice and maturation effects are not involved. Furthermore, it does not require two tests, so it has many advantages over parallel form and test-retest methods. Therefore, it is the most frequently used method of finding internal consistency of the classroom test. So the formula used for the reliability of the full test is Spearman-Brown prophecy formula as given below. The reliability of the full test is equals to 2 into reliability of the half test divided by 1 plus reliability of the half test. Now, what is the parallel form reliability? In parallel form reliability, we have to create two different test form, the same content to measure the same learning outcome. So the easiest way to accomplish this is to write a large test of questions that addresses the same content and then randomly divide the question into two sets. Now it's time to administer both instruments to the same students at the same time. The correlation between the two parallel forms is the estimate of reliability. One major problem with this approach is that you have to be able to write lots of items that reflect the same content. This is often no easy to do a job. Furthermore, this approach makes the assumption that the randomly divided halves are parallel or equivalent even by chance. This will sometimes not be the case. The parallel form approach is very similar to the split half reliability described earlier. So the major difference is that the parallel form are constructed so that the two forms can be used independent of each other and considered equivalent measure. For instance, we might be concerned about the testing a threat of to internal validity, and we use form A for the pre-test and form B for the post-test. We minimize that problem. It would even be better if we randomly assign individual to receive form A and B on the pre-test and then switch them on the post-test. So with split half reliability, we have an instrument that we wish to use as a single measurement instrument and only develop randomly split halves for the purpose of estimating reliability. The next is what is the internal consistency of the reliability. In internal consistency reliability estimation, we use our single test. This test is administered to a group of students on one occasion to estimate the reliability. In effect, we judge the reliability of the instrument by estimating how well the item that reflect the same content gives similar results. So we are looking at how consistent the results are for the different item for the same construct within the measure. Therefore, there are a wide variety of internal consistency measures that can be used. According to the Richardson reliability, says that the estimate of internal consistency of the test are commonly calculated by using the Richardson methods, and he says that these measures to extent to which item within one form of the test have as much in common with one another as do the item in that one form, with corresponding item in an equivalent form.